To calculate the neutral feeder for an assembly hall, we need to follow a series of steps. Let's start by focusing on a 2000 square foot assembly hall with a 120/240 volts electrical system and a balanced lighting load. Firstly, determine the lighting load. In this example, we're assuming the lighting load is balanced, meaning it's evenly distributed across all phases. Since the system is 120/240 volts, each phase supplies 120 volts. Secondly, calculate the neutral current, often denoted as in. The formula to find in is the lighting load per phase divided by 120 volts. This calculation will give you the amount of current flowing through the neutral conductor due to the lighting load. Thirdly, it's crucial to determine the neutral feeder ampacity, represented as in. The ampacity is the current carrying capacity of the conductor. Considering the continuous load, apply a safety factor of 1.25. So N is equal to N multiplied by 1.25. This ensures the neutral feeder can safely handle the expected current. Fourthly, select the nearest standard ampacity. Once you've calculated N, choose the nearest standard ampacity value available for the neutral feeder from the National Electrical Code tables or manufacturer's data. This ensures compliance and safety. Fifthly, optionally, you can calculate the neutral current rating, ICAR, particularly if you're dealing with a three-phase system, although that does not apply here. The formula for ICR is the lighting load per phase divided by 208 volts. This step isn't always necessary for single-phase systems, but it's a good practice for more complex installations. Sixthly, compare ICR to N. If ICR is less than N, the selected neutral feeder ampacity is adequate. However, if ICR is greater than N, a larger neutral feeder is required to safely handle the current. Let's put this into some numbers. Suppose after calculating, N comes out to be 30.7 amps and ICR turns out to be 25.3 amps. In this case, because ICR is less than N, the neutral feeder ampacity is adequate. These calculations help determine the appropriate size of the neutral conductor for a 120/240 volts electrical system in an assembly hall with a balanced lighting load.